Today's class we are going to discuss about batteries. Okay, so here two types of batteries will have. They are primary and secondary batteries. We are going to discuss about primary and secondary batteries. What are primary batteries? Examples, as well as what are the secondary batteries and their examples. So before going to that, let's see some basic characteristics of battery. So if you have pen and a notebook, please note down. A battery is a combination of two or more galvanic cells in series. We have discussed about galvanic cells in the beginning of electrochemistry, isn't it? So by the combination of two or more galvanic cells, we can make a battery. So battery is nothing but combination of two or more galvanic cells. A useful battery should have the following characteristics. Generally, a good battery, a useful battery, have some characteristic properties. What are the properties of a good battery, useful battery? It should be light and compact. Battery should be light in weight, less weight and compact. Compact means we can easily carry from one place to another place. And its voltage should not vary appreciably during its uses. That means the voltage should be constant. Suppose if you are using a battery, after half an hour or 1 hour, its voltage is fluctuated, means the electronic devices cannot function properly. For example, you are using calculator, if you are using your watch, you are using your wall clock, all these devices have some batteries, so they should have a constant voltage, right? Next, it should be long lasting even when it is not in use. Means long lasting means long life. They have long life, more durability should be more. Even the battery is not in use, it should have long life, right? And these are the main characteristic properties of batteries. Generally, the batteries are of two types. The first one is primary batteries, and second one is secondary batteries. And the topic that we are going to discuss in this class is a very simple. And if you are preparing for board exam like CBSE board exam or intermediate exams, and whatever the notes I am giving, whatever the topics I am explaining you on the screen is enough for you. Suppose if you are preparing for competitive exams, along with this class, you better go through your textbook and underline few more important points that you feel they are important and they need to be remembered. Okay. So here I am going to explain you the topics very easily, simply. So how many types of batteries are there? There are two types of batteries. So first one is primary and second one is secondary. So what are primary batteries? Primary batteries, after their use over a period of time, they become dead. Means they cannot be reused. And the cell reaction is completed and this cannot be reused again. So simply the simplest definition is primary batteries are, they cannot be reused. They cannot be reused. Once the battery is dead, we have to throw that battery out. That's all. It cannot be reused. Shall I give you one small example? In your home, you use batteries in your wall clock. In wall clocks or in a TV remote controls, we use batteries, no? Once the battery is dead, that means the lifetime of battery is over. What you do? You throw that battery out and you will buy one more new battery, and again you start using your device, that is your remote control and all, isn't it? Once the battery is dead, it cannot be reused. Such batteries are called primary batteries. That's all, very simple. What are primary batteries? The batteries which cannot be reused once it is dead. Okay, example for this is dry cell or Leclanche cell. Dry cell or Leclanche cell, Mercury cell. Okay, and we'll go to its construction and components. how it is looks like and its arrangements and all. We'll see here. What are the components of dry cell or Leclanche cell? Must you see in any battery or any cell, there are three main components. There are three main components. They are anode, cathode, and electrolyte. Okay, try to remember anode, cathode, and electrolyte. What is anode here? Here the anode is zinc container. Zinc container means whatever the outer surface of the battery, that itself act as a anode. In which? Dry cell. Cathode is a carbon rod surrounded by powdered manganese dioxide and carbon. So anode is zinc container, cathode is carbon rod which is surrounded by powdered manganese dioxide, and the space between the electrodes is filled with the moist paste of ammonium chloride and zinc chloride. You will understand this. Now I'll come to the structure of the battery here. This battery you might have seen, isn't it? This is a very commonly used battery. Once you open the battery, whatever you are using in your remote controls or wall clocks, you break that battery, you can find one black carbon rod inside that battery. This black carbon rod is nothing but cathode. Okay, this container is there, no, the cover, the body of the container, which is a zinc sheet. The zinc sheet is, itself act as a anode. Okay, the zinc sheet itself act as anode, and in between the battery, in the middle of the battery, you can find a carbon rod which acts as cathode. Between cathode and anode, there is an empty space. That space is filled with manganese dioxide, carbon black, and ammonium chloride paste, moist paste. Okay, moisture. Okay, so these are the chemicals or electrolytes, electrodes and electrolytes present inside the dry cell. So once again, I will go back to the previous slide. Now you can understand. Anode is zinc container. That means the body of the battery itself, and cathode is the carbon rod in the middle of the battery, which is surrounded by powdered manganese dioxide and a carbon powder. And the space between the anode and cathode is filled with a moist paste of ammonium chloride and zinc chloride. That's all. So very simple arrangement. This is the battery we use in our day-to-day life, in our wall clocks and remote controls. And what are the reactions at anode and cathode taking place in a Leclanche cell or a dry cell? These are the reactions. You don't worry about these reactions. Okay, you don't be panic. Just go through this reaction. If you can remember, practice the reactions and try to remember. If not, okay, leave it. No need to worry. But you try to remember the electrode potential, the voltage of the battery, 1.5 volts approximately, 1.5 volts, right? And if you can remember this, it's okay, well and good. If not, no need to worry. And what is the use of this primary cell? Where you use primary cell? We use the primary battery in transistors, clocks, and remote controls, right? Wall clocks and all. Next, mercury cell. This is also a second example for primary battery. This mercury cell is a little expensive, costly, and but durable. Its lifespan is very high. You might have seen this mercury cell. Have you seen this mercury cell? Mercury battery. It's a small type of a button, like our shirt buttons will be there, no? And I will give you one small example. Watches, hand watches. Okay, you can find small batteries, and moreover, you can also find in small electronic devices the small button type of batteries. These are nothing but mercury cells. These are also once we can use. After it is dead, we have to throw it out. So mercury cell is another example for primary battery, right? Here zinc is here anode is a zinc mercury combination. It is called zinc amalgam. Anode is zinc amalgam. So here mercury is used now, so it is called mercury cell. zinc mercury combination. It's an alloy. It's an alloy. Alloy means the combination of two or more metals, zinc and mercury. So it is called zinc amalgam or an alloy. Cathode is a mixture of mercuric oxide and a carbon. So this anode, cathode and electrolyte, these three parts you try to remember. If you cannot remember the reactions, no problem, but try to remember at least what is the anode, what is the cathode and electrolytic substance. Okay, this is about mercury cell. That's all. These are the two examples for primary batteries. Next, what are the electrode reactions taking place in this mercury cell? Okay, these are the electrode reactions, and you can just have a screenshot of this, or you can have you can practice from your textbook, no problem. And no, don't worry about these reactions. Okay, whenever I say this is important, then you try to remember, and if you can remember this, okay, otherwise no need to worry. But my suggestion is to remember the electrode potential value, that is the voltage of the battery. Mercury cell or mercury battery's voltage is 1.35 volts. Okay, before this we have discussed about a dry cell or Leclanche cell whose potential is 1.5 volts, isn't it? So these voltages you try to remember. Next, where we use this? In a small electronic devices like hearing aids. Those who cannot to hear, that is some deaf people will be there, no? They use some hearing aids. Those hearing aids include small batteries, mercury batteries. These are costly also. Watches, cameras, okay? All these include mercury cells. Next, one small question to you. In a dry cell or Leclanche cell, the cathode is, what is the cathode? Cathode, anode, electrolyte. These three components you try to remember. In a dry cell, the cathode is carbon, right? And anode is zinc, right? Okay. Next, what is electrolyte? Carbon powder, moist carbon powder, and manganese dioxide. Next, a depolarizer used in Leclanche cell. In dry cell or Leclanche cell, what is a depolarizer? Try to remember this point. Note down this point. Depolarizer is manganese dioxide, MnO2 is act as a depolarizer. Next, in Leclanche cell, zinc rod is placed. 100% ammonium chloride, 20% ammonium chloride, 30% ammonium chloride, or 40%. Okay, 20% ammonium chloride we use. All these points are there in your textbook. You no need to worry. And just I have collected some important points and I'm putting in front of you, right? Next, secondary batteries are those batteries. See, what is a primary battery or primary cell? The primary cell is the battery which can be used only once. Once the battery is dead, we cannot reuse it. We have to throw it out. That is a primary battery. Secondary battery is a battery which can be recharged. Can be, once the battery is discharged, again we can charge it. Can you give an example of secondary battery? In our day-to-day, regularly, daily, we use a secondary battery. Where it is? In our mobile phones. The battery or the cell present in our mobile phones is a secondary battery. How can we say it is a secondary battery? Because once the battery is discharged, okay, again we can recharge it. Daily we charge our mobile phone. That means what? It is a discharging and again we are charging. Discharging, charging, discharging, charging means the battery is not going to dead. Okay, again we can recharge it. Such batteries are called secondary batteries. The definition is very simple. A battery which can be reused again and again. A battery which can be reused again and again. Otherwise, a battery which can be recharged is called secondary battery. A secondary cell, after its use, can be recharged and can be used again. A good secondary cell undergoes large number of discharging and charging cycles. Large number of discharging and charging cycles. That means, see, once a mobile phone is bought, we'll charge the mobile phone regularly on a regular basis, daily. Suppose I'm using a phone which I have bought 7 years back. Still I am using it. The same battery. Means every day I am charging it for the past 7 years. That means it has a large number of discharging and charging cycles. Okay, such type of batteries are called secondary batteries, right? And examples for secondary battery, one of the best examples is a lead storage battery. This is the first example. And this lead storage battery will see on a regular basis in our cars, buses, lorries, in almost all vehicles, even in our motorcycles we see this lead storage battery. This is used to provide electricity in the vehicles. The vehicles need electricity, for their starting the vehicle, or for the headlamps are there in the vehicles for signaling purpose. Okay, this lead storage battery is used. And moreover, we use lead storage battery more frequently in our homes as an inverter. You might have, almost in these days most of the homes are having inverters. When there is a sudden power cut, immediately the inverter start working, and we don't feel that the power cut has happened in our home, right? Isn't it? So in all these equipment, lead storage batteries are used. This is an example for what? Secondary battery. It also have anode, cathode, and electrolyte. Okay, what is anode and what is cathode, what is electrolyte here? So go through this. Negative plates which filled with a spongy lead. You can just have a rough notes of this, because anode, cathode, and electrolyte, these 3 points are important. So in lead storage battery, what is anode? So anode is a negative plates of lead grids. These are all the lead grids. Lead means Pb lead. Lead grids, negative charged lead grids plates, which are filled with spongy lead. Between these, 38% of sulfuric acid is used. This acts as electrolytic solution. Electrolyte. Next, let's see. The group of lead plates bearing compressed spongy lead is anode. Cathode is a grid of lead packed with lead oxide is a cathode, and electrolyte is 38% sulfuric acid. Right. Next, when the cell discharges, this reaction takes place. Right. Here, this reaction is important. One thing is here, you no need to remember both the reactions at anode and cathode. At least you have to remember the overall reaction. So this is the reaction takes place at anode. What's the reaction at anode? Lead and SO4 minus 2. These are H2SO4 is there, no? Sulfuric acid. From sulfuric acid to sulfate ion, SO4 minus 2 ion combines to give lead sulfate. Lead and sulfate ion gives lead sulfate, and 2 electrons are releasing here. So this is loss of electrons. This is oxidation process. So oxidation takes place at anode. And at cathode, lead oxide combines with the sulfate ions and H plus ions, and also 2 electrons, gives lead sulfate and 2H2O. So here also lead sulfate is formed. Here also lead sulfate is formed. And this is anodic reaction. This is cathodic reaction. This is oxidation because loss of electrons. Here gain of electrons. This is a reduction reaction. If you can remember, practice this reaction, these two reactions, and try to remember, or at least the final reaction. This final reaction will come from these two reactions only. Here 2 electrons get cancelled. These 2 electrons get cancelled. And what is left on the left side? This is an arrow mark. Left side to the arrow mark, Pb is there. So Pb I have written. SO4. Here also one SO4. Total 2 SO4s are there. 2 SO4s and 4 hydrogen ions. So total 2 H2SO4. 2 2s are 4 hydrogens. Here 4 hydrogens. 2 2s are 4 hydrogens. 2 SO4s. 2 SO4s. SO4 minus 2, SO4 minus 2. So overall this becomes 2 H2SO4. And here PbO2 is there. PbO2. That means Pb plus PbO2 plus 4 hydrogens and 2 SO4 minus ions. So complete totally 2H2SO4. This is the reactant part. On the product side, PbSO4, PbSO4, 2PbSO4 and 2H2O. 2PbSO4, 2H2O. This is the reaction takes place when we are using the battery. That means suppose you have a cell phone, your mobile phone. Just for example, I am giving just to make you understand. In your mobile phone, when you are using the mobile phone, this reaction taking place, this reaction will takes place inside the battery of your mobile phone. Actually, just to make you understand, I am giving this example. Actually, this is not the reaction taking place inside the battery of your mobile phone. So your battery consists of some other chemicals and the reaction will be different, but it will be similar, right? So otherwise you can take directly whatever the inverters we use in our home, that you can use directly. So we are using the inverter in our home. This is the reaction actually taking place inside the inverter. So Pb plus PbO2 plus 2H2SO4 gives 2PbSO4 plus 2H2O. And till the inverter is working, till the inverter is discharging, this reaction takes place continuously. So this is the reaction taking place during discharge of the cell. Next, once the cell is discharging and it lost almost of its charge, no, then what you do, again we charge the battery. On charging the discharge battery, when you charge the battery again, the above reaction is reversed. Whatever the reaction we have seen in the previous slide, and the reverse reaction takes place when we are charging the battery. That means, do you understand? In our mobile phone, whatever the battery is there, that battery one reaction is going on when we are using the battery, when we are using the mobile phone, when we are watching the YouTube videos or WhatsApp or Facebook, and for any general purpose, when we are calling to our friends, then slowly and steadily the battery will discharge. After a few hours, what we do? Again we charge the battery. When you are charging the battery, the reverse reaction takes place. Reverse reaction means what? Again I will go back here. This will come to reactant side and this will go to product side. Then you can write here, reverse reaction of this you can write here. 2PbSO4 plus 2H2O gives, note down in a notebook, 2PbSO4 plus 2H2O gives Pb plus PbO2 plus 2H2SO4. So that reaction, reverse reaction takes place when the battery is charged. In charging process, water is consumed and H2SO4 is produced. In charging process, note down this point. Water is consumed means water is used up and H2SO4 is produced. This already we have seen. See, during charging, this water is consumed means this water is utilized, and which will be produced? Sulfuric acid will be produced. That's all. Next, lead storage cell can be represented as, this is the representation of a lead storage battery that we use in our vehicles and inverters and all. Okay, note down Pb bar PbSO4 double arrow. This is the representation of galvanic cell now, and this is the representation for salt bridge. Pb is in contact with PbSO4 and H2SO4 is the electrolyte. So PbO is in contact with Pb, right? And where it is used? In automobiles and inverters. Nickel cadmium battery. This battery appears to be normal cell. Whatever the cells we use in our remote controls and wall clocks and all, it looks like in the same manner. But the thing is that cannot be recharged. But nickel cadmium battery can be recharged again. Okay, and it is having a positive plate, negative plate, and a separator. Between positive plate and negative plate, there is a separator, partition. So that is nickel cadmium battery. And in nickel cadmium battery, anode is cadmium, cathode is nickel oxide. Cathode is nickel oxide, and electrolyte is aqueous solution of potassium hydroxide. As I told you, you try to remember anode, cathode, and electrolyte in each of these batteries. Okay, overall cell reaction is this: cadmium plus nickel hydroxide gives cadmium oxide, and nickel hydroxide plus H2O. Where we use nickel cadmium battery? In calculators, portable power tools, means a small size some devices, electric devices or electronic devices. Okay, a few questions are given here. Which of the following is a secondary battery? Dry cell, Leclanche cell, mercury cell, or lead storage battery? Okay, what's your answer? Dry cell and Leclanche cell as well as mercury cell are
Lead
primary.
storage batteries.
Yes, good. First three are primary batteries and the last one is secondary battery. The equivalent weight of sulfuric acid in a lead storage battery. This is an important point because generally equivalent weight of sulfuric acid is 49. Generally, usually in all the cases, equivalent weight of sulfuric acid is 49, but here it is 98. So why we'll see. So actually for equivalent weight, the formula is equivalent weight is equal to gram molecular weight by number of electrons involved, or valency we can say. So equivalent weight of molecular weight of sulfuric acid is 98. How 98? Hydrogen atomic weight 1, 2 hydrogens are there, 2. Sulfur atomic weight 32, 2 plus 32, 34. Oxygen atomic weight 16, 16 fours are 64. Oxygen atomic weight 16. 4 oxygens are there, no? 16 fours are 64 plus sulfur 32 and hydrogen 1. 2 hydrogens are there. So if you add all these, you get 98 by 1. Actually, in sulfuric acid, 2 electrons will be involved, generally 2 electrons. So 98 by 2 we have to use, then we'll get 49. But here what happens? 2 moles of electrons are involved for 2 moles of sulfuric acid. 2 moles of electrons for 2 moles of sulfuric acid. Then for 1 mole of sulfuric acid, 1 electron, no? 1 mole of sulfuric acid involved, 1 electron. Just to make you understand, I will go back into the previous reaction I have mentioned. See here, see this reaction. Yes. How many sulfuric acid molecules are there here? 2 H2SO4. 2 sulfuric acid molecules. How many electrons are involving? 2 electrons are involving. No? 2 electrons. For 2 sulfuric acid molecules, 2 electrons are involving. So, one sulfuric acid, 1 electron. So, that's the reason. So 98 by 1 we use here, so 49. You no need to worry about all these calculations and all. Just you remember one point. In this lead storage battery, the equivalent weight of sulfuric acid is 98 instead of 49. Usually in all other cases it is 49, right? That's all. Okay. These are the things we need to concentrate regarding batteries. So here in this class, we just discussed about what are primary cells and secondary cells, primary batteries and secondary batteries, and along with examples. I hope you have taken notes for this, and this notes is enough for you for your board exams, even for competitive exams. Okay, if you want to go little more into this topic, and you have to remember and learn the reactions given in the electrolytic process. Some other points you can get from your textbook. Okay. Next, we have left with the last topic in this chapter, that is fuel cells and corrosion. And that we will cover tomorrow. And by tomorrow, this chapter electrochemistry, all the topics will be completed by tomorrow's class. So afterwards, what we do, that based on your interest. Suppose if you tell me to start some objective questions given in a previous NEET and some other competitive exams, I will explain you the previous competitive exams questions. Otherwise, if you say, sir, we'll go to next chapter, I'll start next chapter. The next chapter will be our first chapter actually, that is solutions. I have skipped that chapter, solutions, because some of you need electrochemistry, so I have started this. For example, if you want solutions, I'll start with solutions. Otherwise, if you tell me to start chemical kinetics, I'll start chemical kinetics. Whatever, based on your demand, I'll start the class next class. You just message me in our group, so that next we'll plan on Sunday or Monday onwards. The next topic will start, whether the previous questions or next chapter. Okay, you please message me, and based on that, I will take the next class. Okay, dear student, tell your friends also to join our classes. And because watching YouTube videos may not that much, what to say, productive, because here you can have a chance to interact with me. Suppose if you get any doubt in between, you can speak with me. But in the recorded video, you cannot have that opportunity. And tell your friends who are interested and who are preparing seriously for competitive exams to join in our WhatsApp group and also follow our classes. So probably whenever we will continue the same time, 8:40 to some 9:30 and all, in the coming days also, because this time is I also relatively free, and you may be free after all of your works, homeworks, and coming from the schools and colleges. Okay, after completing complete 12th class syllabus, then I'll start 11th class syllabus. And we have to have a long journey throughout this year. 1 year I have planned for this long term coaching. Okay, have a nice day. Good night. We'll meet in the next class. Bye bye.